Okay, so let's start. Yeah. So let me first tell you the checkpoints. These are the checkpoints, and in this chapter we will be learning about the chemical reaction equation. Am I audible, Datta?
Yes.
Yeah. So chemical reaction equation, types of chemical reactions, and effects of. And my screen is visible, right?
Yes.
Okay. And the last one is effects of oxidation reactions in everyday life. So let's start with the very first topic, which is chemical reaction and equation. So as you have told that the process of interaction of chemicals to form new chemicals is called chemical reaction, right? Got it? So can you please tell me, will you please tell me the example of a chemical reaction? Any formula? Sorry, any equation? Go ahead.
O2 plus
Which one?
H plus O2.
Yeah, H2 plus O2 is equal to H2O.
Yes, ma'am.
Yeah, hello, ma'am.
Yes, sir.
Yeah? Okay. Got it? This H2 plus O2 is equal to H2 is a chemical. And we can also write it like this. Ma'am, will you please switch on the microphone because my voice is equal. Hydrogen reacts with oxygen to form water. H2O is water, right?
Yeah.
Yeah. Now, what is chemical equation? Any idea? What is chemical
Chemical
equation?
reaction is.
What?
I don't know how to put it in a sentence.
Sorry?
I'm not sure how to put it in a sentence.
Oh, okay. So it's a symbolic definition of chemical reaction that involve the use of formula and symbols. We can also say a mathematical representation. So let me write mathematical representation. We will provide you the PDF of this note. Mathematical chemical reaction that involve the use of formula. Formula and what was that? Come on. Formula and what? Huh? Symbols, right? Now, what is the example of this?
Mg plus O2
Yeah,
equals to
H2
MgO.
plus O2, H2O. So this is my reactant and this is my product. Correct? Hello, what's your name? Okay. So, the very first chapter of chemical. This is the chemical reaction. Just a minute. This is the chemical reaction. The checkpoints. What we will be learning in this chapter is chemical reaction, equation, types of chemical reaction, and effects of oxidation reactions in everyday. Okay. Now, your name? Your voice is not audible. That girl. Okay. So, what is chemical reaction? Interaction of chemical forming two chemicals. Like we will add H2, then we will get H2. This is a new chemical which we are getting. This interaction of the H2 and okay. Okay, Datta? Yeah.
Yes. ma'am.
And equation is what? Mathematical representation of chemical reaction that is formula and symbols. This is my formula, H2 and O2. This is my formula, right? So this side, the left hand side is reactant, and the right hand side is got it? Any confusion? Any confusion you can ask? Any doubt? Will you please switch off the microphone because my voice is breaking. Yeah, please switch off that. Thank you. Now we will be learning this. What is balanced chemical reaction? What is balanced chemical reaction? What is this? Do you know balancing? Anyone of you? Do you know balancing? How to balance the equation? Anyone? No one? Okay, so let me teach. Let me choose this title. Okay, so a chemical equation having an equal number of atoms on both the sides. Okay, means chemical equation having an equal number of atoms on both the sides. On both the sides means we will be having the equal number of atoms on the LHS side and on the RHS side. So let me give you an example. Let's say this is H2 plus O2 giving H2O. Now we have to balance this equation. How to balance this? Anyone? Anyone know? Nobody? Okay. No. First, let me write like this. H2 plus O2, H2O. For example, there is 2. Okay. And now we have to balance this and this. Because in H, there is 4 atoms and here it's only 2 atoms. So what we can add to either LHS or either RHS? Anyone? How to balance this equation? It's a very simple reaction which I'm taking. Anybody?
You'll add 2 to the LHS.
What?
You'll have to add 2 on the LHS.
Yeah. 2H2 plus O2 will give 2H2O. So my question is balanced here. See, oxygen is having 2 atoms and hydrogen is having 4. Here also hydrogen is having 4 and oxygen is having 2. So 4 atoms on each side. Correct? Got it?
Yes, ma'am.
Got it? Any confusion? Audible, right?
Yeah.
Yes. Now let us learn the more conditions in reactions. More conditions. More conditions in reaction. Example, let us take heat, sunlight, and pressure. Okay, heat, sunlight, and pressure. Now, for example, if you are taking yes, calcium carbonate with CaO and CO2. If we heat this, what is this CaO? What is the name of this? This is what? This is calcium.
Calcium oxide.
Yeah, calcium oxide. Correct. Good going. Calcium oxide. This is normal carbon dioxide, and this is calcium.
Dioxide.
No. Try. What is this? What is CaCO3? Calcium carbonate. Okay. If we will heat this, this is the symbol of heating. Okay. If we will heat this calcium carbonate, we will get calcium oxide plus carbon dioxide. Any confusion? See, now we are studying the more conditions in reactions. So first we have the heat. So if we are heating the calcium carbonate, we are getting calcium oxide plus carbon dioxide. Okay. Now second we will take the example of this sunlight. First we have took the example of heat. Now second we will take the example of sunlight. This is like 2 AgBr. What is AgBr? 2 Ag plus Br. In the presence of sunlight, if we will do like 2 AgBr in the presence of sunlight, it will be 2 Ag plus Br. Okay. And what is pressure? The third one. Sorry, this is my first one. More conditions in reaction. This is the second. Second one is let me use this white pen. Gas liberation. What is gas liberation? What is liberation? Okay. What is liberation? Anybody?
From the evolution of the gas.
Yeah.
From evolution of gas.
Me?
From evolution of gas.
Yeah. Yes. It's like that only. So far we have discussed this. This means this symbol, right? For heating, we use this delta type of symbol, or you can say the triangle symbol. And now for gas liberation, we will use this symbol, this upside arrow. Okay. For example, let me take the same example only, then it will be okay for you guys to understand. Let me take the same example. Sorry. Yeah. CaCO3. If we will heat this, what we will get? Come on, fast. If we will heat calcium carbonate, what we will get? I've just told you. No one. Datta, you?
CaO and CO2.
Yeah, CaO and CO2. And here in the liberation one, we will do like this. Like the arrow will go upside. Means CO2 is, CO2 evolved because CO2 is a gas, right? CO2 is a gas. Agree? And CO2 is evolving. So we will use the arrow of upside down over here because CO2 is a gas and it is evolving because we are studying the topic of gas liberation. Liberation means evolving of a gas. Okay, got it? Yes, any doubt you can ask me. Now, third topic is my catalyst. You was not there, right? So I was talking about the gas liberation. Liberation means evolving of a gas. Means CO2 evolved. In this equation, CO2 is evolving because CO2 is a gas. Okay? Okay. So this one catalyst. The next one, the fourth, and the fifth one will be precipitate formed, and the physical state. The physical state. So far we have discussed about the chemical reaction. Done? Chemical reaction done? Any doubt? Come on, fast. Any doubt? No? Chemical equation done? No doubt. Balanced equation. We have seen here that how we can balance the H2 plus O2 giving H2O. Now, more conditions in reaction, where we will use this heat type of triangle in this type of equation, this sunlight in this, and now we will learn the catalyst, precipitate form, and the physical.
Excuse me, ma'am.
Yeah. I'm so sorry. Okay, yeah, sorry. So catalyst. Anyone know about catalyst? What is catalyst? So I've just told that any substance that increases the rate of a reaction without getting itself consumed. It means that, for example, there is any substance, okay, that increases the rate of reaction. Means it will increase the rate of reaction. It will, increase the rate of reaction in such a way that it will do their, job faster and faster. So, but without getting itself consumed, it's not consuming. Only it is increasing the rate of reaction. So that type of thing we called catalyst. Now, example, let's say if we will take, let's say A plus B giving C. This is my 2.5 kg. This is also my 2.5 kg. Now, for example, 35 minutes it took for the reaction. Both 35 minutes for a reaction. They both are taking A plus B giving to C. Whole this reaction is of 35 minutes. Let's say But there is one x. For example, if we will write here x, what x will do? Can anyone tell me what x will do? Anyone? No one? Okay.
It,
So what? Yeah. Go
it
ahead.
increases rate of reaction.
Yes, correct. Because very good. Because X will act here like a catalyst. X will increase the rate of reaction without getting itself consumed. Only it will increase the rate of reaction. For example, here my total rate of reaction, which is going like total is of 35 minutes. But X will increase the reaction. Maybe it will, all the reaction will happen only in the 10 minutes, not in the 35 minutes. Only it will increase the reaction. It will not get consumed without itself being consumed. Okay, so X, here we will call X as a catalyst. Okay, done? Done? Yes, done. Now precipitate formed. Next topic is catalyst done. Now precipitate. Getting it right? Sorry, formed. You, Datta, and you. Till here, any doubt? Any confusion? Any doubt? No? Yes or no? Come on. No. Okay. So what is precipitation reaction? What is precipitate? Okay, let's make it easy. What is precipitate? Anyone? What is precipitate?
A substance which is insoluble in water.
Very, very good. Yeah, reduce insoluble salts. We can say it like that, right? Reduce insoluble salts. Reduce insoluble salts. Now, let's take one example here. PbNO3 twice. Let's say, obviously, aqueous. Now, what is this? What is AQ? What is AQ?
It means that
Sorry. Now, 2Na aqueous, PBl2, this is solid, and plus 2NaNO3, this is my aqueous. And what is PbNO3 twice? What's the name of this? Come on.
lead nitrate.
Lead?
Nitrate.
Correct. Lead nitrate. And what is this? Come on. What is this?
Sodium iodide.
So, sodium?
Iodide.
Yes. Perfect. Sodium iodide. And this one? No. This one is lead iodide. And this NaNO3 is sodium nitrate because sodium nitrate. Here, if we will write here like this arrow, this one, this is the symbol of precipitation. The upside one was the symbol of liberation, means gas was evolving out, and this is the symbol of precipitation, the downwards. Okay, it means we can also write it like A plus B, giving equation C plus D, and here this one means precipitate. Okay, now just a minute. Yes, this done. This is also done. The precipitation thing done. This equation example, and now let's study the physical state. What is physical state? Let me give one example. Physical state. So CS plus O2 is what? 3 plus O2 is what? Carbon and oxygen is what? Anybody? Nobody? It's CO2. Yes. Now let us take one more example. Yeah, let us take one more example, which is, sorry, your voice is breaking. Your voice is not audible. NaCl plus H2O giving Na aqueous and Cl aqueous. Let us take these two examples. So here, how many states we are showing? How many states are here? Can anyone tell me? How many states are here? Come on, you, Datta. Come on, tell. How many states?
3.
3. Which one?
Solid.
3. Solid, liquid, and?
Gas.
No. Yeah, that's correct. But here we have 4 states. Solid, liquid, gas, and the last one is aqueous. Correct? Aqueous. AQ is aqueous. Now, what is aqueous? What is AQ? What is aqueous? Anyone?
A solution of the substance in water.
Which is dissolved in water. Correct. Aqueous is dissolved in water. Sorry. This is aqueous. Got it? Physical state, aqueous. So here all 3 done. Catalyst done. Precipitate. What is catalyst? Come on. I will not show you guys. What is catalyst? Datta, you?
It increases the speed of the reaction.
Yeah.
Without being consumed.
Yeah.
Without being consumed.
Correct. Very good. And what is precipitate? Precipitate means produce insoluble salts. And last one is the physical state. Here we have seen the 2 examples. And aqueous is there. So aqueous means dissolved in water. Now let us study the 4 types of chemical reactions. What is 4 types of chemical reactions? Can you name them? No? Sorry. It's reaction, not equation. 4 types of chemical reaction. REA to the power N. Means reaction, just like a short form. 4 types of chemical reaction. What's that? Tell.
Combination reaction, decomposition, displacement, and double displacement.
Very good. You know everything, right? You know everything. So here we have first combination reaction. Then what was that? What was that, Datta? After combination? Decomposition.
Recomposition. And displacement. Double displacement.
displacement and double displacement reaction and the DD reaction, which means double displacement. Okay, now let us first study about the what is combination reaction. What is combination itself means that we are combining something, right? Combination means when two or more reactants combine to form a single product. When A or B, for example, this is my A, this is my B. Okay, let me show you guys one diagram. Let's say this is my this one. Yeah. For example, this is A, this is B. So two or more reactants combine to form a single product. Means A and B. It's combined. Easy. This is what two reactant. We can also use two or more here. Two or more reactants. This is what combines. Combines to form a what? A single product. Just a minute, guys. Yeah. Sorry for disturbance. Got it, na? What is combination reaction? When two or more reactants is combining to form a single product. Here A and B is two reactant. They are combining to form a single whole product. Got it? Done? Easy? Like if we will use this, so C plus O2 is combining and giving us a single product, which is CO2. Yes? Done? Any doubt? Any doubt, anybody? What is a combination reaction? Okay, so no doubt. Good. Now, what is decomposition reaction? What is decomposition? Decomposition reaction. What is decomposition?
When one single reactant breaks into smaller product,
It
forms two or more smaller products.
Yes, very, very good. It's just the opposite of combination. In combination, we are adding two or more reactants to get one single product. But in decomposition, what we will do, we will in the left hand side, we will have the one single reactant. It will combine and form two or more reactants. Single reactant will combine to form two or more products. Let me just, show, like this is my A and B, right? So this is my A, this is my B, this is my single reactant, and it is combining, single reactant is combining to form what? To form a two or more products. A plus B. This is what? This is two or more products. It can be 3, 4, 5, two or more products. Okay, done. Let me take this example. CaCO3. This is my single product. The one whole CaCO3 means full calcium carbonate is combining to form a CaO plus CO2 means calcium oxide and carbon dioxide. Okay, can any one of you will tell me what will be the symbol of this equation? What we are doing here? We are heating. Heating. So which symbol we will use?
A triangle.
Yeah, the triangle one. Delta one, the triangle one. This we will use. So if we will heat the CaCO3, we'll get CaO and CO2. This is a decomposition reaction. Means single reactant combining two or more products. Now, third one. Third one was what? Was the displacement reaction. Now, what is displacement reaction? See, displacement reaction is very easy. For example, here is my A. This is my A. Okay. Now, this is my B and C. It will combine and it will form like A and C plus B. This is a displacement reaction. Like a more reactive element displaces a less reactive element for its compound. Okay. Let me give you another example like ZnCuSO4 is giving what? ZnSO4 plus Cu and this arrow. This is my precipitation wala arrow. So here what is going on? Since zinc is more reactive than copper, it threw copper out, right? And here copper is crying that no, I'm alone. And zinc is more reactive. So the element which is more reactive, the another element, it will throw out that element. Like here, A is more reactive here. Here, A is more reactive. B and C combine. So A will combine with C and C will throw B out. Here, like as zinc will throw the copper out from the equation. You have to memorize this like ZnFeCu. ZnFeCu, what does it mean? It means zinc is more reactive than copper and zinc is more reactive than iron and iron is more reactive than copper. See here, zinc is more reactive than iron and iron is more reactive than copper. Correct? Here, zinc is more reactive than copper. So that's why zinc throws out the copper this side. That's why we are discussing this formula that you will get to know that which element is more reactive and which is not. So zinc is here more reactive, then Fe and then C. Correct? It means got it? Now this is my displacement. Now we will learn about the double displacement. So displacement was little tough maybe. It was tough? No? Now double displacement reaction means DD reaction. Let's use this short form. Now what is DD? This is my A and this is my D and this is my B. This is my C. It will become A, C plus B and D. See here double displacement happens. Here only one A is throwing C out, means C is throwing C out and A and C are combining. But here ADBC and then it will be AC plus BD, double displacement. It means exchange of ions, and if you all want to like say it more specifically, then you can say a mutual exchange of ions is happening here. What is happening? Mutual exchange of ions. Or you can also say exchange of ions are happening. Mutual exchange of ions are happening. Okay, let me ask you guys some questions. Here, Cu plus ZnSO4. Is this is correct or wrong? Come on, tell you. Sorry, tell me. Because see, here Zn means zinc is more reactive than iron than copper, now. And here is copper and then zinc. So it will be like zinc is less reactive here than, sorry, copper is less reactive than zinc. So this equation is not satisfied. Correct? Everyone, come on, tell, got it or not?
Yes, ma'am.
Yes, ma'am.
Example of this, NaOH plus HCl. Examples are very necessary to write because in exams, you like a definition will not only work, the example will also work. NaOH plus HCl will be what? What will be the LHS of this? Come on, it's easy. It will be Na. Yeah, yes, correct. NaCl plus H2, NaCl, and here H2. Oh, done. So this is done. My four types of chemical reactions. Combination was what? Two reactants are combining to form a single product. This decomposition is the opposite of combination. It means only single reactant is combining to form two or more products. And what is displacement? Displacement, in this displacement, you have to summarize this. You have to memorize this formula, Zn, then Fe, then Cu. And here in double displacement, there will be a mutual exchange of ions taking place. Now, there are, how many types of reactions are there? Anyone? Types of reactions? No one? There are two types of reactions. One is, it's very easy. Come on.
Thermal.
What?
Thermal, endothermic, and exothermic.
Perfect. One is endothermic, another one is exothermic. It's very easy. Endothermic and exothermic. What is thermic? What is thermic?
Related.
Yes. Thermic is heat. Just a minute. And what is endo? Endo means going inside. It means heat is going inside. This is endothermic. Means thermic means heat and then endo means going inside. And what is exo? Exo means coming out. Just opposite of that. It means if we will, say in a very chemical term, then it will be energy release. And here energy gain. Energy release. And this is my heat or energy, both you can say. Okay, means supplying of energy inside, we call it as endothermic, and energy is releasing, we call it as exothermic. Perfect, got it? Easy or not? Easy. Now energy is supplied, it means endothermic. Energy is evolved, means exothermic. Supplied means going inside. It means energy is supplied here. Energy is supplied. Just a minute. Any doubt till now? Energy supplied and energy evolved. Energy is evolved. है ना? Correct है? Correct. Supplying of energy and evolving means releasing of energy. So let me give you guys one example. Sorry, straight line, but chalega. So let me give an example. It will be CaCO3, CaO plus CO2. This and this. Here is what? Energy is supplied. Means the gas liberation. Hai na? This upside down was the symbol of gas liberation. Correct? And here also one example of exothermic. Yeah. Of exothermic will be CH4 plus 2O2 will be CO2 plus H2O plus energy release. Means here my energy is releasing. Hai na? Because it is exothermic, my energy will release. This is endothermic, my energy will supply. Now, here and here one more point we can say that here is photosynthesis. We will wait, photosynthesis, and here we can use respiration. Respiration means what? If we are respiring, means my energy is releasing. Photosynthesis means what? The plant is making food from sunlight, from water, from soil, from whichever. Means energy is gaining in the plant. So it will be energy is supplying. And in the exothermic, if we are doing the respiration, then my energy is releasing. It means energy evolved. Got it? Any doubt? Any confusion till now?
No.
No? Okay, perfect. Now, we can say that decomposition is the example of endothermic. Decomposition is also example of endothermic. So, the energy which we are supplying, that we will learn in three forms. Means in endothermic, my energy is supplied, right? So we will learn in the three forms. Let me use this one. Three forms. Sorry, three forms. What it will be? It will be in the form of heat, in the form of light, in the form of electricity, in the form of heat, in the form of light, and third one in the form of electricity. Means energy which we are supplying, which we are evolving in the form of these three: the heat, the light, and the electricity. Okay. So how can I say that decomposition is an example of this endothermic? Let me tell decomposition. See, in decomposition we have three things. One is my photosynthesis. No, like photolysis. Second one, electrolysis. Sorry, and the third one is this. Third one. Now, what is this? What is this? This is means light. Means to break the chemical. We use photolysis. Means breaking of a chemical by using the photo. Photo means light. Wait, let me sorry. This is in the form of light. Electrolysis means electricity one, and thermolysis means okay. Photolysis means what? To break the chemical, we use photo means light. To break the chemical, we use photo. Photo means light. Photo in the form of, and what is electrolysis? In the form of electricity. Here in the form of photolysis in the form of light, electrolysis in the form of electricity, and the thermolysis in the form of heat. This means breakdown. Okay, got it? Decomposition. Endothermic is in three forms: the heat, the light, and the electricity. Light means the photolysis, electricity means electrolysis, and the heat means thermolysis. And the lysis means the breakdown. Means here the breakdown of a chemical with the help of a light. So this is known as okay. Done. Please got it. Now let me elaborate these three things, which will be first photolysis. Photolysis means let me give you one guy's example. That for example, here is my, let me use this white pen. Here is my silver chloride turns gray in sunlight to form a silver metal. From here my sunlight is coming. Sunlight. Follow the jaldi. Yeah, hello. Sorry, due some network issue. Am I like visible? My voice is audible now? Okay, I'm so sorry due to some network. It's raining here, that's why. So we were talking about the photolysis. So it will be like, here is sunlight, and this white in color is my silver chloride. Silver chloride turns gray in color in the form of this sunlight. Let me write silver chloride turns gray in sunlight to form what? To form kya? To form silver metal. Silver chloride will turn gray to form silver metal only. Silver metal means example AgCl will Ag plus Cl2 in the form of sunlight. Now let me explain. Here is photolysis, and we know to break the chemical we use this light thing. We use this light thing. So sunlight is what? Sunlight is a light. So for example, we have kept silver chloride in my window, and if sunlight is coming, then it will turn gray in the form to form this silver metal. Silver metal, we can give this example here. AgCl will be Ag plus Cl2. Now, yes, now electrolysis. Can anyone tell me? Oh, it's already 3:59. Wow. Okay, what is electrolysis? Means electricity, right? And lysis means you already know, means to break down. So, what is happening? Chemical is breaking with the help of electricity. Chemical is breaking. In electrolysis, chemical is breaking with the help of electricity, because electrolysis is happening. Chemical is breaking with the help, with the help of electricity. Can any one of you give me example here? What is the example of electrolysis? Anyone? It's very easy. Anybody? Okay, so it will be H2 plus O2. H2O. It will be H2O giving H2 plus. Got it? Done. Photolysis, electrolysis, and then thermolysis. Photolysis means light. Electrolysis means electricity, and thermolysis means this heat. In the form of heat, it will break down. Now, for redox reaction is remaining. Many are remaining. We will discuss in the next class. It's already 4 o'clock. So how was the class? Let me just, summarize this full thing. We have discussed about the chemical reaction, means the process of interaction of two chemicals to form new chemical. Means H2O2 is forming a H2O. This is reaction. Means reaction is happening. Second one, equation. What is equation? Means mathematical representation of chemical reaction involving a formula and a symbol. Means H plus O2. This is my mathematical equation. It will be H2O. What? Anyone? Now, balanced chemical reaction, we already know. H2O2, we are balancing this. Now, the next one we have discussed about the more conditions like heat, this delta in form, sunlight, and the pressure